Chapter 9, Section 5 and 9 go together. So this is where we're going to do our first shift of the chapter, and we are now going to look at natural and common logarithms. So far we have been looking at exponentials, and logarithms are the inverse of exponentials. So that's why they go together in this chapter. The first thing we'll do is look at the common logarithms, and the common logarithm equation is y equals log base 10 of x. Okay, so if you are going to graph that in your calculator, y equals log base 10 of x looks like this. Okay, so it's kind of, okay, the inverse, it's not kind of, it is the inverse of an exponential. Okay, and remember, I'm just going to draw this in so you can remember, all of our exponential graphs looked like this. Okay, so the relationship to this is it's the inverse of y equals 10 to the x. Okay, so basically, if you remember from inverses in chapter 8, the domain and the range switched. Well, if I just look at my logarithmic graph right now, I'm going to go ahead and say, okay, my domain, as I move from left to right, I'm going to start to see it on the positives, so I'm going to say x is greater than 0. The range, as I go bottom to top, I'm going to see it everywhere. So my range is going to be all reals. So if you remember, that is the opposite for exponentials, and obviously they should flip because they're inverses. Okay, the intercept here is going to be 1, 0. I didn't draw that super accurately, and I'm sorry, it should run through 1, 0. And the asymptote, so again, that's the line that the graph is not going to cross or touch, and it used to be the x-axis, but clearly we're crossing the x-axis, and this time our asymptote is the y-axis, so our asymptote is vertical, okay? And the base, okay, is this number down here, okay? So it's log base 10. So let's go ahead and see what some of these problems look like. Okay, these are going to be no calculator type problems because we are going to evaluate them. So if I have log base 10 of 100, what this really means, okay, because they are inverses, is 10 to what power equals 100. Okay, so we're saying 10 to what power equals 100. So what I kind of do is I say, okay, if I'm going to evaluate it, let's put it equal to x, okay, and you're always going to take your base, and you want to know to some power, okay, to equal 100. So I kind of think of it as like the circle of life. Okay, you always start at your base, and you go to the right. So 10 to what power is 100? Well, that is 2. Okay, so our answer here is 2. If you were to type in your calculator log of 100, okay, your calculator knows the 10 part already, it would automatically give you 2. So we're just trying to do this mentally to know where the calculator gets these answers. Okay, the second one says log of 1 over 1,000, and it doesn't have a base. Well, it's kind of like the square root where it's implied that the 2 is implied that there's a 10 here, okay, because the common log has a base of 10. So now I want to know 10 to what power gives me 1 over 1,000. Well, if I just said 10 to what power gives me 1,000, you would say 3. And if you remember from chapter 7, when we dealt with powers, hopefully remember that a negative power, it took the reciprocal. So anytime I have to get a fraction out, I need to have a negative power. All right, the next one says log base of the 5th root of 10. Okay, again, that's an imaginary 10 there, so if you want to write that, okay, that's just fine. Okay, so if you kind of want to set up an equation to solve here, I'm going to say 10 to what power gives me the 5th root of 10. Well, if you remember from last chapter, the 5th root of 10 is really 10 to the 1/5. So if I'm saying 10 to the what power gives me 10 to the 1/5, okay, you don't overthink that, okay? X is just going to be 1/5 here. Okay, so there are some evaluating ones. Now we'll try solving them. Okay, so now if I just put the x in a different area, again, there's a little 10 for my base. Again, you always start at the base, and you can kind of make your circle here. So I'm going to say 10 to the 5th equals x. What this circle of life is really putting it into exponential, okay, notation. So it's the same thing. Okay, it's just a different notation, and it's easy to solve. Okay, so 10 to the 5th equals x. So x will equal 10,000, 100,000, 5 zeros. There we go. Okay. So now if I look at the next one, log base x of negative 2. Okay, so again, that's a 10 there. So we're going to say 10 to the negative 2 equals x. Again, remember that a negative exponent, okay, flips your answer. So really, 10 squared is 100. So flip it, so that'd be 1 over 100. Again, these are all no calculator problems. Okay. Then I will try the next one. Log base 10 of x equals 1/4. So I'm going to say 10 to the 1/4 equals x. Well, I don't know 10 to the 1/4. So if you wanted to write the 4th root of 10 as your answer, That sounds about right. Otherwise, you could just lean at 10 to the 1/4 because those are the same thing. Okay? So then sometimes I just want you to write it in logarithmic form, okay, and not actually solve it. So this is kind of working ourselves backwards, okay? So if I wrote 10 to the 5th equals 100,000, geez Louise, logarithmic form, okay, says put it with a log. So if I work myself backwards, I would have log base 10 of 100,000 equals 5. Okay, so you kind of put your log in there because you want it logarithmic form. You bring down the 10, because you always start with your base, and then you flip sides for the 10 and the 100,000. Okay, and then it's kind of easy to check because you're going to get really good at putting it into exponential form. So if you want to check, is 10 to the 5th 100,000? Yep, that's what I started with, so that's a good thing. Okay, so logarithmic form means put log, okay, into your answer. The second one, letter H, says write this in exponential form. So exponential form is what we've been doing this entire time. So there's a little imaginary 10 there. Again, you always go to the right. So 10 to the -1 equals 0.1. Okay, so exponential form means just to rewrite it. Again, this is really nice because you can see if you did it right. Is 10 to the -1 0.1? Absolutely, because the negative exponent flips it. So it should make sense, or it should be pretty easy to check to see if you're on the right track. Okay, so that's common logarithms. We also have natural logarithms. So we have done exponentials, and then we also had this thing that was this e to the x, which remember was the same idea, only it was when we dealt with a continuous function. So now we have a natural log, which is y equals ln of x, okay, which is going to go with our e. Okay, so this one is the inverse, okay, of e to the x. So these two are inverses of e to the x. Okay, and how are you going to remember that? Well, on your calculator, you have an ln button, and then e to the x was attached to that. Okay, you also have a log button, and the short one is 10 to the x. The reason those buttons are the same, okay, is because they're inverses of each other. Okay, so that's kind of nice. If you were to graph ln of x, okay, it's going to look just like the log, okay, because both of those exponential graphs look the same. So therefore, our domain is the same as before. And so is our range, which is the inverse of what we looked at earlier in the chapter. Again, our intercept is 1, 0, and our asymptote, again, is the y-axis. Okay, so the exact flip of exponentials. Okay, and our base here is e, because it's the inverse of e to the x. So let's try some of these. Okay, evaluate ln of 1. Okay, well, this base is e, so if we were going to write it out, we'd have e to the x equals 1. Well, what to any power always gives me 1? 0. Okay, fair enough. Then if we try the next one, and I'll put my equals x here so it looks the same. So I have e to the x equals 0.25. Well, do we know powers of e like we know powers of 10? No. Okay, so we don't know this stuff. We don't know powers of e. So, how can we find this? On our calculators. Yay! So all you have to do on your calculator is type in this initial one, ln of 0.25. You should get negative 1.39. Okay? So ln, you get to use your calculator. Logs, you don't. Okay? ln of -5, if you type that in, you're going to get no solution. Okay, well that should make sense because we just talked about the fact that -5 is over here. Is the graph over here? No. Okay, so you're never going to have negatives work out, so you're just going to give me a no solution. Okay, so simplify. Okay, so simplifying here is going to be a little bit different. Again, I know the base of ln is an e, so what's really nice is this e and this e will cancel. Okay, so the ln and e's cancel, so all of that leaves us is 4. Okay, again, ln and e are going to cancel here, but be careful. This 2 comes down to be 8 times 2, which is 16. Okay, so that 2 comes down and it's multiplied. Do not write 64. Okay, and then ln of 0, again, that's going to be a no solution because we don't have anything that is 0 or less. We only have positive answers. Okay, write in logarithmic form. Okay, again, we need to put a log in our answer. However, this e tells me that that means ln. So I'm going to write kind of the reverse. So I'll put my base down first, and then I'll flip sides. So I'll put ln of 7.39 equals 2. Okay, and if you want to check that in your calculator, if you type in ln of 7.39, you should get 2. So that's a good thing. Okay, write in exponential form. That means to do the circle. Okay, the circle of life. if there's a song like that. Base of ln is e, okay, and then there's your circle. So e to the 5.7 equals 300, and that's all I need you to do when I ask you to write an exponential form. Okay, so that's the basics of common and natural logs. Go ahead and write down some questions and bring those to class tomorrow.